purpose of a ground fault safety check is to determine that an inverter's ground fault detection hardware properly detects and indicates that its overcurrent protection device, in this case it's a breaker, is in the open tripped state. A byproduct of this safety check also verifies there is no external fault between the normally grounded array conductors and the connected PV array to the system ground bus. Should an inverter fail this important safety check, the entire system should not be worked on until the problem has been corrected and this check can be successfully completed. Because lethal DC and AC energy potentials exist inside the inverter with the inverter service disconnect switches in the open or closed positions, this safety check should only be performed by electrically qualified service personnel outfitted with proper personal protective equipment and properly rated measurement equipment. This presentation will demonstrate how to perform this check on an SGI500XT series inverter with functional LCD display and indicator LEDs. Press and hold the escape button on the touchpad to stop the inverter from exporting power to the grid. The display will say PAC off. When it does, open the inverter's DC service disconnect switch. Open the inverter AC service disconnect. Wait for the LCD display, LEDs, to go cold, dark, and dead, and they are. Open the inverter enclosure doors. Inside the inverter, locate and open the GFDI ground fault breaker to its open tripped position. Close the inverter enclosure doors. Close the inverter's DC service disconnect switch. Close the inverter's AC service disconnect switch. Verify that the ground fault LED is illuminated. This is what the inverter is supposed to do. If the inverter fails to do this, then it fails this safety check and no further work on the system should be performed until the condition is corrected and the ground fault LED illuminates as it is supposed to. Okay, open the inverter's DC service disconnect switch. Open the inverter's AC service disconnect switch. Open the inverter enclosure door. Okay, set the GFDI breaker to its closed on position. And close the inverter enclosure doors. And the test is complete. Okay, in cases where the indicator LEDs on an inverter are non-functional, we then have to verify the safety electrically using a digital multimeter set to measure DC volts. We've opened the enclosure door. The multimeter is already pre-set up between the system ground bus, the red lead is, and the normally grounded array bus over here on the left side of the inverter enclosure. That's where the meter return is. The multimeter is hanging off of the DC rod over here. So in order to electrically check this inverter, we need only to, with the breaker closed, verify we've got 0 volts DC on the meter. And there's 0 volts showing on the meter. Now, if we open the GFDI breaker, there will be a DC voltage on the multimeter. Now, what the magnitude is of that voltage, we don't care, just that it's there, and it is. So go ahead and then close the GFDI circuit breaker again, and that DC voltage then should go back to 0 volts DC, and it has. So while this does not confirm that the protection circuit in the inverter is functional, it does confirm there are no faults in the PV array wiring and that the inverter can otherwise be serviced without risk of DC electric shock.